So I've got an even-numbered problem from the book here. This is about proving an identity. So we talked about proving identities back in section 5.2, and then we learned a whole bunch of new formulas. We learned the sum formulas, now we've learned the double angle formulas. So we've got a richer toolbox to work with in proving our identities. So here, I'm going to say this is my left-hand side. This is my right-hand side. And I want to try to prove that they're equal, remembering cardinal rule, I'm only allowed to work with one side at a time. Okay. Now this is definitely the more complicated side, so I'm definitely going to need to work with it at some point. But I think I'm going to start with the left-hand side, because secant of 2x would just be 1 over cosine of 2x. And so I don't need to have a whole separate formula that I'm going to memorize, because I can always derive it by just saying this is going to be the reciprocal of the double angle formula for cosine. Now, I've got 3 different versions that I can use. I'm going to just say this is 1 over cosine squared x minus sine squared x. Okay. That's the one that falls directly out of the sum formula for cosine. So it's usually what I start with unless I have a good reason for doing otherwise. Okay. So now let's look at this right-hand side. Now I probably will want to eventually get this in terms of sines and cosines, but I'm seeing that it looks like I should be able to do some factoring here. So I think I'm going to try to do some factoring while I still have it in terms of secants, and then switch to sines and cosines. So let me start by copying what I have. It's secant squared x plus secant to the 4th x over 2 plus secant squared x minus secant to the 4th x. Now on top, both of those terms are just powers of secant. I can factor out a secant squared. So that's going to be secant squared x times 1 plus secant squared x. And remember, I can always double check my factoring by just distributing that back through to see that it would give me back this. Now, on bottom, this is written kind of backwards. I usually like to write things with the biggest power first, and the biggest power would be this piece. I also find factoring to be easier if the lead term, which is the one with the biggest power, is positive. So I'm going to do 2 things. I'm going to factor out a negative, which is going to change the sign of each and every term, and then I'm going to rewrite it in descending order, going from biggest power to smallest power. So this piece was negative. When I factor out the negative, it becomes secant to the 4th x. This was a positive secant squared x. It's going to become minus secant squared x. And this was a positive 2. That's going to become a minus 2. Okay. And then I want to just remember that that's secant squared x squared. Okay. So I can say this is secant squared x times 1 plus secant squared x all over. Now I'm hoping that I can factor this as secant squared x plus something times secant squared x plus or minus something. Oops, and there's that negative that I pulled out from the front. So the first terms would give me secant squared times secant squared gives me secant to the 4th. Remember, I'm hoping that this is the result of foiling. Now if that's going to work, the numbers that go here have to be a 2 and a 1. And I can see one of them is going to have to be positive and one of them is going to have to be negative. And I want to end up with my OI, my outsides and my insides together, being a negative secant squared x. So let's see. If I make the 2 positive, I'd have 2 secant squared minus 1 secant squared. That would give me a positive secant squared. So it looks like I want that one negative. That way I get negative 2 secant squared plus secant squared will give me a negative secant squared. Okay. Now, one thing I like about this is 1 plus secant squared is exactly the same as secant squared plus 1. So I can cancel that. And let's see. I need to clear some space. So I'm going to just record that I have already simplified the left-hand side to be 1 over cosine squared x minus sine squared x. And now I'm working with the right-hand side just to clear some space, I'm going to erase this work and just write what I've gotten to here, which is secant squared x over negative secant squared x minus 2. Okay, so I want to keep going now. With that, at this point, I think I am going to switch things over to cosines. So this is 1 over cosine squared x. And I'm going to just distribute that negative back through as I rewrite this in terms of cosine. So it's going to be negative 1 over cosine squared x minus a negative 2 is going to become plus 2. And I think the bottom will be simpler if I'm able to get a common denominator. So I'm going to multiply this piece by 1 in the form of cosine squared over cosine squared. So let's see, that's 1 over cosine squared x over negative 1 over cosine squared x plus 2 cosine squared x over cosine squared x. Okay. All right, so let's see. I can combine that into a single fraction. So this is 1 over cosine squared x all over negative 1 plus 2 cosine squared x over cosine squared x. Okay. Now, if I'm dividing by a fraction, I can just flip and multiply. So this is going to be 1 over cosine, actually, let me give myself a little bit more space. 1 over cosine squared x times cosine squared x over negative 1 plus 2 cosine squared x. The cosine squared x will cancel, and I've got 1 over, I'm going to just rearrange this and write the positive term first, 2 cosine squared x minus 1. Now, I remember that there were 3 different versions of the double angle formula for cosine. Wasn't sure where I was going before, so I went to this one for the left-hand side. I'm hoping this is also one of them. But I think it's actually going to be easier to get from here to here. So what I'm going to do is say, okay, I've simplified the right-hand side, and this is what I got. I'm going to go back to the left-hand side and pick up where I left off. Okay, so I'm returning to up here. I'm not connecting it to this, but I'm just going to say, I just got something that didn't have any signs in it. So let me use my Pythagorean identity to rewrite that sign as 1 minus cosine squared. And then I can distribute that negative. And that becomes 1 over, I can combine these, 2 cosine squared x minus 1. Okay. So I thought I was done here, so I stopped. Then I discovered that I could actually keep going once I had a more specific goal for where I wanted to get to. Okay. But you'll notice the work for the left-hand side and the work for the right-hand side were separate. I did not assume they were equal to each other. But now that I've simplified them to exactly the same thing, I want to remember this is what I call the 3-paragraph method. So one paragraph was to simplify the left-hand side. The second paragraph was to simplify the right-hand side. Don't forget the third paragraph, which is to say that they're equal. Because, as you might have noticed, this was a kind of a long problem. And so if I'm doing all this work and I just stop, sometimes people are kind of like, why did you stop? Were you tired? Did you need to take a break? And I stopped because I had done what I wanted to do. But you always want to explicitly state that to make it clear. Otherwise, you're leaving it up to your reader to try and figure it out. And you want to say, hey, look, I did what I said I was going to do. So this identity is in fact true.